Let's welcome Bojan. Bojan supports AI and machine learning companies to turn their machine learning models from the data lab into like MVPs and even fully fledged final products. And yeah, despite working on ML, he still decided to join us on the first day, which isn't really about machine learning, but about Python in general. So I'm glad he's here, and he will teach us about refactoring. So having worked in a company where I worked with a lot of engineers that weren't software developers and still wrote Python code, I very well know what it means to refactor lab Python code into production-ready Python code. So yeah, I'm very excited to hear about that. So friendly welcome to Bojan and his talk.
Hello, everybody. It's very nice to be here, and I actually learned some German. Guten Morgen. It's about how much I know in German. Today, I'm going to be talking about how to make your code beautiful. I love beauty, and we're going to create some beautiful things together. Now, about me, I've been working in Python for 12, 14 years. It's been long enough that I forgot when I started. And during this whole time, I've been working on some really, really insane code bases. And I actually managed to create some insane code bases. So I got some lessons to learn how to be better than myself and how to be better than people I got code from. And the first thing I want to cover is the scariest thing in the whole programming. Nothing scares people more than legacy code. I don't think anybody here likes working on legacy code. Yeah, silence is a sign of approval. But there is one thing we need to understand about legacy code. Legacy code is by definition code that works. It brings the value to a company. People are using it. If nobody was using it, we would not be working on it. The managers don't like to waste money and developer resources. And also myself, if nobody's using the piece of code I wrote, I'm not going to work on it. And this is hard for me to say, but it's much easier to write a code than to write a program that people are using. So whoever created the legacy code in any shape or form has actually managed to solve a problem for somebody. So I want to take a moment to just acknowledge that legacy code is great. It's a controversial thing, so I'm going to give applause. You can join me if you want. That being said, there is one activity in our life that I really like to compare to refactoring, and we all encounter it. That is washing dishes. When you only have one dish, it's super easy to refactor it, wash it. But as you go along, it keeps piling up and piling up. At one point, from I'm going to do it in a few minutes, it goes, I'm going to do it tomorrow, to I'm going to do it next week, to I'm just going to wait until it evolves and moves out of my washing machine. So if you start keeping your code base in line, it's going to be easy. But if you just leave it alone, it's going to get very stale very fast. Because no matter how beautiful your code is, you're writing it with today's standards, with today's libraries. And what's good today is probably not going to be good in 20 years or 5 years. So just remember, don't get too attached to the code. You can love it, but it's going to require maintenance, like a car, like any piece of technology that we are using. It needs a love. And refactoring for many developers activity, I want to refactor this code to make it better, to make it more beautiful. And for me, that is a very good reason, but you should never refactor code to make it more beautiful. You need to have a very good reason why you're refactoring. And I'm going to go over 3 reasons why you should refactor your code. If it's not one of the mentioned, you should not refactor your code. You should take your kids to the Lindt chocolate factory that I'm going to visit this weekend. You should watch a movie, do something else. Don't refactor a code. There's no need for that. So, First thing is performance. You want to make your code faster. Now, here I mean not the actual performance. I'm going to rewrite my Python code in Rust. It's going to run 100 times faster. And that means absolutely nothing. Because if your code was running 100 milliseconds and it was serving user requests, and I rewrite it and it's running in 5 milliseconds, nobody cares. It's faster, but no user is going to notice that, and you just wasted 3 weeks. So I'm talking about performance that's going to have measurable and sensible impact on users, on business. If it's something going to be, for example, you have a script that runs for 1 hour, and it's running every day. You rewrite it to be half as fast, to run in 30 minutes. That's super slow, but it's running half an hour faster. That's much more impactful than making a script that's running for 50 milliseconds in 1 millisecond. Like, in one case, it's twice as fast. In other, it's 50 times as fast. But first time, it's going to be much, much more impactful. So before you start to optimize it, take in consideration, is this going to make an actual impact? Because we love making numbers go down, but you need the context behind those numbers. Second reason is, it's buggy. We all remember that in our code base, there is a certain black hole, swamp, dark forest where scary stuff happens, and it's usually creating majority of the bugs in our code. When you have something like that, you need to go there and rewrite it. You don't want to keep working on the same code, because what happens there, you keep adding patches, and you're patching it, and you're patching it, and it gets worse and worse and worse and worse over time. So that's a valid reason to refactor it. Second one is very related to this one. You have, and I put these two together because you have a piece of code that's completely outside of how the rest of the system is done. It can be because you outsourced it and you didn't really care about it. It could be because it was the first piece of the code that was written in your company. And you want to align it with the architecture. Same as above. Does this make sense to actually do that, or can I focus on something that's going to create more value? If it's going to make my job easier, are you going to work on that code? That when it makes sense to do architectural alignments. And also when it's super slow to add features. This makes sense if you are constantly working on improving that software. But if you have one feature per year and it takes you 2 hours to add it, or maybe even a week to add it, and if you refactor it, it would take you maybe an hour, it makes no sense to refactor it. It's going to take you more time to refactor it and add a feature than just add a feature. So the most important skill you're going to need before refactoring is common sense, and it's not very common. I speak from my own experience because I don't have it in great capacity. So also, now I'm going to give you one really very important secret. Now, I'm pretty sure everybody has touched the code that did some refactoring. Do you know what is the most complicated part of every refactoring? Any guesses? Excellent guess. Well, it's not coding, it's not testing, but it's close. It's the other people. As Tatter would say it, hell is other people. And most important person that's going to stop you from doing the refactoring is your manager. Because they need to approve stuff and let you, I'm going to work on that. The second person is whoever worked on that code. That can be the company you inherited all of this from. That can be yourself, because I consider myself a completely different person from who I was 2 weeks ago, because whatever I wrote there, that's somebody else. I have no idea what was happening there. So it's always people, not the code itself. You'll see working on the code is very simple. It's collaborating, getting approval for that. And management is super hard, but it's also very predictable because they're going to ask you some very standard questions. And before you go to your manager and tell them, I want to refactor this code, here are a couple of questions that they're going to ask. And the first one is, how much is this going to cost? And if you don't know how much it's going to cost, they are not going to approve it. Because you may say, well, it's going to be like 10,000 euros, then I'm going to take a few weeks. Okay, and what do we get for this? If you don't know that, they're going to be like, there's another feature we need you to work on. How long it's going to take? Because for some reason, management likes to do management. And it's weird to me as well. They want to know how many people we need to assign this, how long are you not going to be available to work on other things. So you need to have an idea. And I'm going to be first to say this is like one of the hardest things to answer, because when I look at the very strange, bizarre code base that most likely I created, I have no idea how long it's going to take me to rewrite it into something readable. And the third one, this is where the whole common sense things come. What are the actual benefits of this? Because people want to know, okay, if you do this refactoring and I let you do it, what's going to happen? What is the impact on our business? If you say, well, nothing, but I'm going to feel nicer, they're going to say, I'm going to buy your cookies and you're going to feel nicer. Now, the refactoring is more of an art than a science, but there are some steps that I'm going to share with you. So first step, whenever you want to do some refactoring, is to basically play Indiana Jones. You want to understand the archaeology of that code. What the hell happened there? So you understand, what is this code? Because you can't refactor something if you don't know what is working. And this might sound obvious to you, but I used to work in software lifecycle development and management. It's a handful, but that's how my department used to be called. And that means you get software from outsourcing company, and then somebody tells you, okay, this piece of code is producing bug. What does it do? We don't know. Where is the documentation for that? The original company didn't give us. So you have something, you have no idea what it's doing, you need to fix it. So hopefully you will have some person you can talk to, some piece of documentation. But that's the first step, figuring out what's happening there. Second one is, how can I run this? You cannot refactor the code that you cannot run, because you're going to break it, and you need to know when you break it. And as somebody who did a bunch of debugging in production, it's not a very fun experience you want to have in your life. And after you have managed to run the code in your local environment, you know what it's doing, only then you can proceed to refactor it. I sometimes like to jump steps ahead. It doesn't matter, it's not running on my machine. I know how to refactor it. It never ends up well. And after this comes one step that I'm going to be repeating through this whole presentation. And that's because this is the most important step. And as somebody said, it's testing. First thing you want to do when you start refactoring, before you even touch the code base, have tests. Like, don't change anything. Don't change the variables names. Don't look at the code wrong if you don't have tests, because code tends to break down. And if you have no tests, it tends to break down all the more. And if by some miracle, you have good colleagues and you have inherited or even wrote some tests, that's good. Don't trust those tests. Go and take a look at the test and see if they are actually doing what they are supposed to do. Because somebody likes to write tests, they don't cover all the edge cases. Or you discover, okay, if I'm optimizing for performance, then you need to add tests that measure, okay, this was the performance, this is what I want it to be. But make sure that you have a really good test coverage before touching anything. If you don't have this, don't do refactoring. Next step is going to be improving readability. And you're going to spend majority of your life reading code, and very small portion of that writing the code. And I would like you to leave the code in a better place than you were when you found it. Because it doesn't matter if it's yourself, if it's your team members, or anybody else. People need to understand what's happening there. And the first thing there is names actually matter. You need to have very good naming convention. I'm going to give you an example of one of the smartest people I worked with. He had a few PhDs. I did not know people could have a few PhDs before that. And he wrote a brilliant piece of code. But his variables will name A, B, C, D, E, F, G. And I was actually like super, okay, I'm interested into this story. I want to see how it's going to develop. He got to Z, and I'm like, is it going to be A1, A2 now? No. This person was way smarter than that. Alpha, beta, gamma, delta. He started Greek alphabet. Needless to say, it took me like 3 weeks to rename that into something that I could understand. And I want to show you something. This is a piece of Python code. If X is not none, or if X is none. This means absolutely nothing. It's always going to be true. And you're going to forget this in about 5 minutes. And why I'm showing you this? Because this is equal to one of the most famous phrases in English language. To be or not to be. It's the same, it's just named differently. It's how you write the code. This is the difference between readability. You could have something as trivial as that everybody's going to remember. Or you could have something as above that you're going to forget. I'm going to forget that code. And I wrote this. Next thing about improving readability, you really want to have smaller pieces of code. All of modern IDEs, like PyCharm, for example, I'm going to talk about PyCharm, but that's because I started working with PyCharm like 10 years ago, and I'm too lazy to change it. But VS Code, Z, whatever is popular right now, they all support refactoring. So whatever you like, use that. If I mention PyCharm in my talk, don't take it as I'm going to need to use PyCharm. Use whatever you like. It's just what I use. So you can right-click and then refactor, rename. Name the function, name the code, whatever you like, into something that's more readable. Enter, it's going to change it. Then you run tests. Always run tests, because you might say, okay, I just renamed the variable. How can that break things? Never underestimate how insane previous developers were. They might be doing some dynamic stuff. They might be loading variables by string names. Like, things can break. Always run tests. And whenever you have some piece of the code, and usually what you get is like 10,000 lines of code in one function. Might sound strange, I saw that. While you're working to code, making it more readable, you're going to write comments. Okay, this paragraph is doing these things. That's good. You have identified one hole. Select it, right-click, refactor, extract as a method, and name that as something meaningful. And just keep doing that. And if you can continue to do that, you have improved the readability. You haven't changed the functionality. You haven't changed anything in the code, but you have broken it out into smaller pieces of code. And what do you do when you have improved the readability and broken into small pieces of code? Testing, 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 testing. Now, for all those small segments, you can write unit tests. And code base is getting better, and you're not doing anything brilliant. And the next piece of the stuff is isolating areas of impact. Now, this is very important. Once you do all this improved readability and things, you want to change, but you want to make your change as small as possible. Because smaller the change, it's less likely it's going to break things. And you really don't want to be responsible for bringing the whole system down. Now, there is a very good reason why Google has, over the years, released like 20 different messaging apps and deprecated all of them. It's easiest thing of refactoring is to stop at the step 1, burn the whole code base and write it all from the start. Does not require you to understand anything, does not require you to write tests. You can start all over it. Google does it all the time with their apps. They just deprecate stuff. Sadly, not all of us are Google or we have money to burn like that. So most of the time you are going to be changing existing application. And it's much harder to change something than to write it from the beginning. That's why you need to understand all of this. So make your changes as small as possible and make them count. If you want to optimize performance, as I mentioned, one of the reasons why you should do refactoring is you want to measure it. And you want to measure it quite nicely. Because when I was starting, I was doing all that manually. Right, see if it's faster. Good, all good. Right, again, after my changes, it's faster by 2 seconds. Excellent. That's not how you measure performance. Because at the time, maybe something else was running. Maybe my browser was loading YouTube. Maybe somebody else was doing some stuff on the network. Who knows? You want to run it at least 10 times, then get the average or median from it, and that's your base value for before and after. Never measure once, measure 10 times. And that's how you do the performance measurement. The more time you measure it, more certain you're going to know if you made any changes. Because one time, when I was optimizing for performance, I was like very sure, okay, Redis is single-threaded. I'm going to replace it with this whole cluster, and it's going to be super fast. And it was much, much slower. And I tried then the second solution that was going to be also super fast. It was slow, because it turns out the bottleneck was on AWS, the EFS, the distributed storage. That was the slowest part, not all the database and architectural stuff that I thought was. So measure things and try to identify what is actually causing the slowdown. And if you did all the previous step, you can profile the code and you can pinpoint, okay, this little function, that's where things are slow, and you know what to improve. So it all connects together. Now, how do you make your code beautiful, and how do you keep it beautiful? Well, it's very easy. Answer is the other people. So create PRs and get somebody else to look at it. That's super slow because other developers have their own work to do, which is weird to me, but they can't all jump in and help me. But second set of eyes can help you catch all the crazy stuff that you missed. And usually having somebody else on the team is going to say, okay, I don't understand this. What's happening here? And when somebody doesn't understand your code, that's not your invitation to attack them and say, no, let me explain what's happening. It's for you a signal to know, oh, I need to improve readability of this piece of code. Then you go in and you change it and make it easy to understand. Because the reason people don't understand your code in PRs or likewise is because they don't have all the context. And all the context that they have is the code. So you haven't written down everything. And what they are missing right now, that's what you're going to be missing in a week and a half. So take your PRs very seriously. All the feedback you get and all the stuff, that's not attack on yourself. That's just try to look at it from their perspective. You have much more information than they have at that moment. But you really want to make it really beautiful. And another hot topic is LLMs. How do you make a good code with LLMs? All of the above. You make it readable, you create a bunch of PRs, you add static linkers like graph, you create GitHub, GitLab pipelines, actions that are going to verify the code, they're going to run the tests, they're going to check it for security, because LLMs can be nice for writing the code, but they're going to get you 95% of the way. And you need those additional 5%. You need to know what's going wrong there. If you don't spot it, somebody in PR will say, okay, this is missing the point. And when you're refactoring a code base that was written by LLMs, it's very nice, but it's also like it was written by 20 different people. Each function tends to be in their own coding standard, completely different from the others. So it makes your job easy. Here in that way that you first need to realign it to look like it was written by the same person. One of the best pieces of code I saw was written by 50 people, but it looked like it was written by one person. You want to reduce the reading overhead. I'm switching out to this function. It's completely different from the rest of the code. LMs really easily introduce that. And for me, this is the moment where I ask you questions. Ask me anything.
Questions in the audience? There's one in front, one back. So the one in the front first.
Thank you for the presentation. It's very nice to see how other people are doing it. But at some point you mentioned that you have to convince your management that you need to refactor, that you need to clean up the code. And when people tell me about that, I always wonder, why do you have to teach your manager their job? Where did you get that manager from in the first place? Why do you have to explain to him what technical debt is and where did he come from if he's in a tech company?
Oh, well, it's very easy. People understand usually in management roles what is the technical debt. But the larger companies, the more people are competing for your time. And there's a bunch of priorities to navigate because clients always want new features and higher ups always want new features. And they need to balance all of that out. Sometimes management underestimates how important the technical depth is and how managing it is. Because they're always going to have on the plate, okay, we need to test these 5 features. And also another thing about why you should convince them is I want to encourage you all to think, because if you have answer to those 3 questions, then you can convince yourself that you don't need to do it. So it's convincing your manager to do it, but also convincing yourself not to do it. Because I would like you to have more free time and spend your time on the code that actually matters. Because I'm very easily distracted, so I'll jump in and refactor something that doesn't need refactoring. So that's my
Thank you very much.
Question over there, the back.
Thanks. Thanks for the nice presentation. You mentioned code readability, which makes total sense for me as a human. But in the light of fast advancements of the copilots of the world, which you also mentioned at the end, do you think in 5 or 10 years this will still be a valid point? So will we still write the code in the same way? So will the code look the same way?
Yeah. I mean, what happens with LLMs and all the machine learning, it gets the average code out of the GitHub. And if you ever went to GitHub, like majority of the code there is horrible. So it doesn't create the most beautiful code. It does the statistical stuff and predicts the code that's going to solve the solution. So for me, if computer can create a good code, it should create a readable code. And the readable code is readable code for humans and computer. I mean, everything is readable for computer. It can write it in assembly. But I want AI that's good enough for where I can understand it's producing the code. Because right now, AI can convince you very nicely that it has written the code and that it's working. But I always catch up, oh, you're doing something wrong here. And for that, you need some seniority and you need to be able to catch those stuff. I think there was a recent study that AI-assisted coding introduced about 40% more bugs. And it's not because it's bad, it's because we trust it a lot. The same thing happened with the GPS. Like, there was a story when a person just went off the road into forest because they trusted GPS. Right now, it's much better, right? I came here using GPS. I didn't walk into any walls, but technology needs to develop. And I don't think development is going to be detrimental to readability. We just need to hold the machines and the other developers in our team to a higher standard.
Another one in the back.
Yeah, thank you for the talk. Maybe two little questions. First, what do you test? What should you test all? And then, I heard you also work with machine learning. How can you test like models that predict that you rather want to measure the performance, or if you have an LLM app that produces different outputs, how can you test, or what's the difference between testing and evaluation?
Good questions. So for the first question, it really depends, but you want to test that your code doesn't break everything else. So some basic end-to-end testing should be there. And as you go deeper, it's going to be unit tests. If your code is mostly doing integration with third-party services, you're going to be doing a bunch of mocking. Because if I'm doing something that's working with AWS, I want to see what's happening when there's no network, when I provide wrong credentials. And if you're running tests, you don't want to be hitting AWS all of the time. So a bunch of mocks, and it really depends. For the second question, working with regular code is hard. Working with machine learning and LLMs is magnitude of degrees harder because you can't simply write unit tests and I don't have an answer in 5 minutes. You need to, there's a bunch of metrics you need to track and all of that. Just catch me up after this and we can talk.
There's a question on the left, then on the middle.
I would like to do a quick mental exercise. So let's say I have already a framework for, let's say, good quality in my team, but I'm the only one who kind of is holds that standard. I'm wondering what would be your approach, and probably in your own team as well, you didn't all appear at the level of having all the tests or let's say the code quality on 100%. So what would be your approach if you go more into the, let's say, not allow it merging into main, or you would go little by little to educate the software engineers?
Okay, so how do you keep other people from destroying your code base? If I can paraphrase it.
Rephrase.
So the first thing is I tried by setting the boundaries to have 100% test coverage, and that didn't work because it's very hard to get to 100% of coverage, and I find it like 90, 85 is perfectly fine. It's you don't have to be dogmatic, and also if something breaks in production, there are no tests to be written. Like you need to fix it and push the fix real fast. So I don't have any hard set of rules on what is the good test coverage. Higher the better, but also is it worth it to spend like 2 days to get it by 1% higher? Probably not. It all depends on the domain. Like if you're working with medical stuff, you want to have 100% and plus. If you are working on logging for web app, like 80% is perfectly fine for me. Like it depends on the domain. And other thing is PRs, but also having a dedicated part of the day for doing PRs, because what I discovered is the longer the PR, it's faster to get reviews for it. Because if I write like 2 functions, I'm going to wait 2 days, I'm going to get 20 comments of that. But if I commit like 1,000 lines of code, I'm going to get looking good to merge right away. Like, so keep your PRs short, and also as a reviewer, book a section of your day. Say, today I'm going to spend 1 hour just doing the review, and be very detailed into that. And also try to get more people to review it. And work with people, mentor them. That's you need to give to less senior people in your team more of your time so you can have more of your time back later. It requires lots of empathy, and also it requires you to be nice in PRs. It's very easy to forget there is a person on the other side. If you're very mean in PRs and you can't insult somebody or say this is ugly, this is unacceptable, like you need to provide a solution of that, because what's going to happen is you're not going to get tagged in PRs. Other people, I'm going to ask my colleague who's sitting next to me, like, can you improve it? I didn't have an energy to deal with this person. So lots of empathy for PRs, dedicated time for doing PRs, and also being flexible. Sometimes it's okay to allow subpar code if it's going to take too much time to fix it. But you can say, sometimes I'll allow like bad code and say, okay, this is not how I would do it. We don't have time to do it, but let's discuss how it would be. In perfect world, this would be the perfect solution. So for me, it's more important that my colleagues understand what's happening there, improve their knowledge, than to improve the code, because later they're going to improve the code on their own. Or some other solution, they're going to write it better.
Right. I think it's time for the break. So, I mean, they can still ask you questions in the break.
Yeah, and I know better than to stand between programmers and coffee.
Exactly. So thanks a lot again. And yeah, enjoy the break.